Welcome back, everyone. In this video, we're going to have a look at the intersection of a line and a plane. Okay, so if we have some plane in blue there, just sort of sitting there like a piece of paper, and if you've got your vector line, your line sort of coming through like in green there, you can imagine sort of like as I've sort of discussed before, having, t is equal to 0, t is equal to 1, t is equal to 2, etc. As the sort of it moves through the line, your parameter, your t parameter there is moving as well. And so what we're trying to do when we're trying to find the intersection is we're trying to, well, what's the t value where the vector equation will satisfy a plane equation? And so that's exactly what we do. So looking at those instructions there, firstly, we make sure we write the line in a parametric form in terms of t's. And then we sub those x, y, and z parametric equations back into the plane equation, and we solve for t. In other words, we're trying to find for what t value does that line satisfy the plane equation, and that will be where they intersect together. Once you've got that t value, all you do is just sub that t value back into the line equation, and that will give you the intersecting point. Now, I'll talk about, there's a couple of I guess things we need to think about here, because sometimes there's no solution, sometimes there's infinite solutions. We'll talk about what that means in a second. Well, I'll do this problem and then we'll sort of think about what would have happened if we did this or that. Okay, so let's have a look at this particular problem here. My voice is gone. So I need to find the intersection of this particular line here, find the intersection of that line and this plane. Okay. So following those instructions before, what we're going to do is we're going to write this in parametric form. So let's just go and do that straight away. So in parametric form, x is equal to 3t plus 13. Y is equal to 2t plus 4. You must be getting good at this by now. And z is equal to negative 2t minus 7. Just double check those with positives and negatives. 3t plus 13, 2t plus 4, and negative 2t minus 7. Yep, all good. So there's my parametric equation. So I've written them in that. What's my second step? Now I want to sub those x, y, and z's back into the plane equation. So what I'm going to do now is I'm going to sub those back into my plane equation. So this is my plane equation. I'm going to circle that. That's my plane equation. I'm going to sub that back into there. And then we're going to solve for t, and then we'll find what t value makes the x values of the line match the x value, the equation of the plane. So we've got 2. What was my x value? It's 3t plus 13. Plus 3. My y value is 2t plus 4. And minus 2. My z value was negative 2t minus 7. And that all equals 4. So I've subbed all that in. Now I just need to solve for t. And when I say I just need to, there's some awful calculations here. It's not that bad. It's just annoying. It's just the sort of thing where you might make a mistake. Let's expand. 6t plus 26 plus 6t plus 12 plus 4t plus 14 equals 4. Let's put all the t's together. We've got 6t, 12t, and plus 4 is 16t. I've got 26, 38, 48 plus 4 is 52, so plus 52 is equal to 4. Therefore, 16t is equal to minus 52 from both sides. I get negative 48. So that gives me a t value of negative 3. In other words, when t is equal to negative 3, then all of the values on the line will satisfy the plane equation. So I hope that makes sense. So we've got this now. T is equal to 3. That's our magic time or parameter, whatever it is. That will create that. Okay, so where will the point be? So let's now sub that back into, well, I'll put the arrow going down that way, but really we're going to now put that back in there to find out what's the x value, what's the y value, and what's the z value when time is equal to negative 3, when t is equal to negative 3. So x is equal to 3 negative 3 plus 13. Negative 9 plus 13 is 4. y is equal to 2 times negative 3 plus 4. Negative 6 plus 4 is negative 2. And z is equal to negative 2 times t. I'm going to write down the bottom and get a bit stuck. Negative 2 times t, don't forget the minus 7 there. And so that's positive 6 take away 7, so that's negative 1. So therefore, the intersection is 4, negative 2, negative 1. So that's my intersection. And that's sort of how it goes. So in that equation, we got with this question, we got a solution. We got a t-value that satisfies that. Now, there's just a couple of things that happen here, okay? If you get no solution for t, so no solution, what does that mean? Well, if you're not getting anything, that means there's no t-value where the line satisfies the equation, and so that means they don't intersect. They do not intersect. Okay, so that's our first sort of thing. Be careful, no solution, they do not intersect. Okay, the second one, you might get infinite solutions. Okay, you might get infinite solutions. Okay, you know, like if you get down and all the t's cancel out and you end up with 6 equals 6 or something like that, you with your t's just cancel out, you're just left with the same thing on both sides. That will be infinite solutions where the value of t does not matter. It's true in every case, and so that means there's infinite solutions. That means the whole line is intersecting. I hope that one makes sense. It's a bit confusing to think about. The whole line is intersecting with the plane. In other words, it's lying on the plane. Can I draw it? I'll draw it in black here. That means that sort of like, sort of that line, it's sitting on the plane. And so every single point along that line is true. It's every single point on the long line. It's sort of sitting on that piece of paper. You can imagine like a pen lying down on a piece of paper. Every point on that pen satisfies the paper's equation. So I hope that sort of makes sense. I'll come back down here just for this solution so that you can see that. But that's how we find the intersection of a line and a plane. See you in the next video.